Just like in an arithmetic sequence and series, in a geometric sequence, if we take all elements and add them all up together, we get a geometric series. And when we have things that we add together, we can always calculate a sum. In the case of a geometric series, we have two sums that we can calculate. We can calculate the sum of a finite geometric series, and the formula for this is S sub n is equal to a sub 1 times 1 minus r to the power of n all over 1 minus r. This is our sum of a finite geometric series, and here's how we use it. In our example here to the left, we have a geometric series a sub 1 is equal to 2. Let's find r. 8 divided by 2 is 4. 32 divided by 8 is 4. 128 divided by 32 is also 4. So r has got to be 4. And now we're supposed to find the sum of the first n, in this case 12 elements. So then S sub 12 is equal to a sub 1, which is 2, times 1 minus 4 to the power of 12 all over 1 minus 4. And for this, we're going to let our calculator help us. As we see, the 4 to the power of 12 is going to get pretty big. And here we go. And here's another useful one. Alpha y is equal to 1 will allow you to put something in the format of a fraction. So 2 times 1 minus 4 to the power of 12. Close our parentheses and move into the denominator, divided by 1 minus 4. And that will give us the answer of a whopping 11,184,810. Whoa. Let's look at our next example, and this one is written in summation notation, so we need a minute to plug out all the things that we actually need. A sub 1 is the number that is here in front, that's multiplied, so that's 1/2. R is the number that's raised to the exponent, and that is 6. And n, we are starting at 1 and go all the way up to 10, so n is equal to 10. And now we got everything we need, and we can figure out S sub 10, because that is exactly what our sigma, our summation, really wants from us. S sub 10 is equal to 1/2 times 1 minus 6 to the power of 10 all over 1 minus 6. And let's use that calculator to help us again. Alpha y is equal to 1 for our fraction. And here we go. 1/2 times 1 minus 6 to the power of 10. Close our parentheses, go into the denominator, 1 minus 6. And we get also not so shabby. S sub 10 is equal to 6,046,617.5. First, let's circle our final answers nicely. And as we had mentioned before, with geometric series, the sums can get really large. Also, the values themselves, as you progress, get very large very fast. And here you have it. And in a geometric series, we can also find the sum of an infinite geometric series, but only under certain conditions. The formula for the sum of an infinite geometric series is S sub infinity is equal to a sub 1 over 1 minus r. But this works if and only if the absolute value of r is less than 1. Why, you may ask, is that only possible for the absolute value of r less than 1? Well, let's take a look at the formula that we used before for our finite geometric series. Our r gets raised to the nth power. What happens then if the absolute value of r is less than 1? Let's look at an example. Let's take a fraction 1/2 and raise it to the power of 2. We get 1/4. If we took 1/2 and raised it to the power of 3, though, we would get 1/8. And 1/2 raised to the power of 4 is 1/16. And as n rises, our fraction gets smaller and smaller and smaller until eventually it is so small that we don't even care about it anymore. And anything we have left in the numerator here is a sub 1 times 1, which is simply a sub 1. On the other hand, if r was a number that was larger than 1, and we're raising that to the power of n, and n also starts getting larger, then this term here gets really big, really fast, and 1 minus that gets very negative, and it goes all the way to negative infinity, so then we cannot take a sum of this expression. So therefore, it's only possible if our absolute value of r is less than 1, because then we end up with just a sub 1 in the numerator of this formula. Now let's look at some examples then. And both of these are again written in summation notation. So let's find the values that we need. We need a sub 1, which in this first example is 6. And we need r, which is 1/2. The infinite sum of this series is 6 over 1 minus 1/2. This means 6 over 1/2, or just simply 12. And let's look at our next example. A sub 1 is 5, r is 2, and since the absolute value of r is not less than 1, we cannot calculate a sum of this geometric series. And now let's wrap this up with an example where we can use the different types of formulas. A pendulum that is released to swing freely travels 18 inches on the first swing, and on each successive swing, the pendulum travels 98% of the distance of the previous swing. And we're supposed to answer a couple of questions here. But before we even do this, let's write our rule for this type of series. A sub n is equal to our first number. Our first swing is 18, and that changes, goes down. It's 98%, so 0.98 to the power of n minus 1. Here's our rule, and now let's go tackle problem A. What is the length of the arc on the 10th swing? Alright, so we're looking for a sub 10. Let's plug that in. We got a sub 10 is equal to 18 times 0.98 to the power of 10 minus 1. 18 times 0.98 to the power of 9, and that is approximately, using your calculator, 15.01 inches. In part B, we're supposed to find on which swing is the length of the arc first less than 12 inches. So we're supposed to find n. Now, plugging everything into our formula, we got 12 is equal to 18 times 0.98 to the power of n minus 1. N is what we're supposed to find. If we only knew how to bring those exponents down. But wait, we do, because we just learned about logarithms. Well, lucky us. So First, we're gonna divide both sides of the equation by 18, and we get 2/3 is equal to 0.98 to the power of n minus 1. Now take a log. Any would work, but I'm taking the natural log of 2/3 and the natural log of 0.98 to the power of n minus 1, which means that we can bring down our exponent now. ln of 2/3 is equal to n minus 1 times ln of 0.98. And now we're going to divide both sides by ln of 0.98. Which nicely cancels out here. So the only last thing we need to do then is add 1 to both sides, and we get ln of 2/3 over ln of 0.98 plus 1 is equal to n. And punching that into your calculator, you get 21.07 is approximately n. That means that after the 21st swing, so essentially on the 22nd swing, the arc is less than 12 inches. Moving on to part C. After 15 swings, what is the total distance the pendulum will have swung? So we are looking for the sum of 15 swings. The sum after 15 swings is a sub 1, which is 18 times 1 minus r 0.098 to the power of 15 all over 1 minus 0.98. Plugging this into our calculator, we get S sub 15 is approximately 235.3 inches. And last but not least, part D. When it stops, what is the total distance the pendulum will have swung? When it stops means when we go all the way to the end, and we are essentially now using an infinite sum. So the infinite sum of this pendulum is 18 a sub 1, that is, over 1 minus r, and that is exactly 900 inches. All right, you guys, that's it for today, and I will see you in class.